No. I hate both. Both of them I equally enjoy.
Okay, page 20.
Because of summer vacation. Wait, what now? Do you know what homework I still owe you?
I think I need to see your previous packet. These pages.
Right,
The rest of this packet, I think.
the 20 through 36.
Yeah, I just need to flip through it, make sure you have all these pages.
Okay.
Yeah.
Or 20 through 46, the whole thing.
Yeah, yeah.
All right.
I mean, yeah, just check through and see what you've already done. Whatever you haven't finished yet, just finish those. All right, so page 20. I think there are some questions about this, especially the last half, so I want to just make sure I go through it with you. So part A says, write the first four non-zero terms. Okay, we can start off with e to the x. We know that e to the x is just what you guys have memorized from the quiz. Or Maclaurin expansion here. So it's just 1 plus x squared over 2 factorial, x cubed over 3 factorial plus x to the n over n factorial. If I want to update that with e to the negative x squared, all I do is replace every x I see with negative x squared. And I also do that with my general term. So my x got replaced with negative x squared. And negative x squared can be broken down into negative 1 to the n times x to the 2n. Okay. So that can be my general term for my adapted Maclaurin series. Part B says use your answer to find the limit as x approaches 0 of 1 minus x squared minus f of x. So I can replace my f of x with what I found for my expansion here. So 1 minus x squared minus, and then my f of x. If I write out just the first few terms, I know that it keeps going, right? Plus dot, 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 all over x to the fourth. And it feels like, wait, so this goes on forever. How am I able to find the limit? Well, the good thing is that a lot of the x's should cancel out because first, let's start off by just canceling out what we can cancel out. And if I were to distribute the negative through, I can see the 1 and 1 will go away. The x squared goes away. I'm just left with negative x to the fourth over 2 plus x to the sixth plus dot, dot, dot. So there's a bunch, infinitely many terms. But if I divide everything by x to the fourth, this is the only term that's going to end up with a constant, which is negative 1/2. Everything else will still have an x remaining. And that x will get pushed to 0, which means that the only thing that's unaffected by with the x approaching 0 is going to be that constant, which is negative 1/2. And so the limit is just going to be negative 1/2. Part C, we're just asked to find the antiderivative of e to the negative t squared. And we have e to the negative x squared, which is essentially the same thing as e to the negative t squared. So we just really have to find the antiderivative of what we built from part A. So 1 becomes x squared becomes x cubed over 3, x to the 4 becomes x to the 5 over 5, x to the 6 becomes x to the 7 over 7. And if we take the antiderivative, we plug in our upper and lower bound, it just ends up being x minus x cubed. Right, it just becomes everything in terms of x. And it says use the first two terms of your answer to estimate the integral from 0 to 1/2. So I just replace 1/2 into the first two terms. And my approximation is just 1/2 minus 1/24, which is 11 over 24. Part D, explain why the estimate found in part C, why is this approximation less than, is off by no more than 1 over 200. And we know that we have an alternating series that converges. All we need to determine our error bound is look at my next unused term. So I can just plug in 1/2 into my first unused term, 1/2 to the 5th over 10. That is less than 1 over 200 because that ends up giving me, my first unused term is 1 over 320, and 1 over 320 is safely under that 1 over 200. Yes.
So because we memorized these like Maclaurin series of like e to the x or like sine x,
Right.
if we're on the AP exam, do we have to show our work for how we found that, or can we just write it in?
You can just start off with this because you don't have to. Are you asking, do you have to derive this formula?
Yeah.
No, you can just write it out. Yeah.
Okay.
Just write it out. Although you could derive it, but that will take a lot longer. But College Board, they will not take off points if you just use your memorization skills to build out your starting. So then our error bound is clearly meeting our criteria because our approximation is clearly less than 1 over 200 since our first unused term is 1 over 320. So I think what I want to do is I want to kind of maybe do one of each type of problem over the course of the next few days in preparation for Friday's test. But we also need to start going into review for everything from first semester as well. So I think tomorrow maybe I'll just do one problem in class, and we'll move into the next set of packets, which is reviewing all the first semester topics that we still need to review. Right. But today, I think we should be able to just focus on the packet. Okay, and then yeah, so let's see if maybe we can do page 21, and then we'll go back and we'll do a particle motion problem like page 11. Right, so let's start with page 21. Yeah, Friday will be a test grade. What do you mean?
I said like Friday will be a test grade.
Test grade, yeah.
Like is that an actual like a test?
It'll test it. Yeah. It'll be 2 FRQs. It'll be one Taylor series and one particle motion. But it's buffered by your homework grade. All right, so spend a few minutes reading this problem and then see if you can get started, and then I'll go through it once you guys had a chance to try it. Yeah, you do have key attached. You can check your progress, but I'd like for you to kind of see if you can start on your own. I think you start off part A with ratio test. So part B is more AB calculus concepts. Any questions with part A? So part A, once we find our potential interval convergence, we test -1 and 1 into our general term. And it doesn't matter that one has an alternator and the other doesn't. Neither of them are able to get past nth term test. The limit as n approaches infinity of n over n plus 1 is equal to 1. That's obviously not 0. So fails, both endpoints fail the end term test. So we don't include -1 and 1 in our interval conversions. Part B, the graph of f minus g passes through the point 0, -1. Find y prime of 0 and y double prime of 0. So y prime of 0 is just f prime minus g prime. So see if you can write out the first few terms of f prime. See if you can write out the first few terms of g prime. And then plug 0 into each and see if you can convince yourself what y prime of 0 is equal to. And then to find y double prime, you can find f double prime and g double prime, plug in 0 for both and see if you can get a handle on to what that value is. And then see if you can use both these values to determine if there's a relative max, relative min. So this is a little bit of having you to try to go through that second derivative test. If my slope is 0 and my graph is concave up, what does that tell us about my graph? Or if my slope is 0 and my graph is concave down, what does that tell me about, what can I conclude about is a relative max or relative min? Okay, so try part B. The part B is really an AB calculus concept problem. So go through power rule to find the first few terms of f prime. Go through power rule to find the first few terms of g prime. So f prime and g prime, they are only going to be left with two constants. All the other terms of x's, which will force them to be 0. So -1/2 minus -1/2 is going to be 0. So that tells us that the slope at 0 is 0. F double prime, we go through second derivative, and we're going to get 4/3 being the only constant. G double prime, 1/12 being the only constant. If I plug 0 in both, if I subtract them, I'm going to get 5/12, which is a positive value. So if my slope is 0, and at the same time my concavity is positive, I must be staring at a relative minimum because my graph is curved upwards, but then that point is displaying a slope 0. We must be staring at a relative minimum. Okay, let's do a particle motion problem. Let's go to page 11. Yeah. You have calculators for the rest of the assessments. So a particle is going to start at point A, then go to B, then go to C, then go to D. And on this path from C to D, we can tell that the Y value is obviously decreasing because it's moving towards 0. And so is the X value is also decreasing because it's moving left. So whatever this X value is, it's going to end up getting closer towards 0 as it moves towards D. So both the vertical component and the horizontal component of my particle, they're both getting headed towards 0. Positive Y and X approaching 0. Part B, the slope of the curve is undefined. So if we think about a slope, slope is defined as dy over dx, but we can break them into their component forms, dy dt or dx dt. And if I want to figure out where the slope is undefined, I'm looking at the denominator, right? It's going to be where my dx dt is equal to 0. So I can just basically set my dx dt equal to 0 and look for my critical point. And if I set dx dt equal to 0, I can basically set both equal to 0. These are basically two separate terms that are being multiplied. I can set that equal to 0, set that equal to 0, and see if they agree. See if I can find an agreement between the p-values that will show them giving me a t-value where both will be undefined. And so if I set the negative 9 cosine of pi t over 6 equal to 0, I'm going to be able to, we'll divide by negative 9, take inverse cosine. Inverse cosine of 0 is pi over 2. and solve for t, I get t equals 3. On this side, inverse sine of 0 is still is going to be pi. And then cross out the pi, solve for t, I also get 3. So t equals 3 is when the slope is undefined at point B. Part C. The line tangent to the curve at point x of 8, y of 8 has an equation of y equals 5/9 x minus 2. Find the velocity vector. We know velocity is related to our slope. So I can set my velocity vector or set my my derivative component equal to my dy dx. Okay. We know that the slope at 8 can be expanded into y prime of 8 over x prime of 8. So y prime of 8, we don't know because the problem says that the y prime is not explicitly given, but we can work our way down to that. We know the overall slope is 5/9. We know x prime of 8 is -9/2. You can plug in 8 into x prime and solve. So then if we cross multiply and solve for y prime of 8, y prime of 8 must be -5/2. And so that will give us our velocity vector. Our velocity vector is just going to be the horizontal and vertical component of our first derivative. So -9/2, comma, -5/2, or -4.5, comma, -2.5. And speed is just the square roots of the sum of the squares of your horizontal and vertical component, right? Square root of dx over dt squared plus dy over dt squared. And that just goes in your calculator. Part D says how far are the points A and D, the initial positions respectively of the particle. The nice thing about points A and D is that they're along horizontal lines, so we don't have to worry about anything with vertical components. It's not going to make any difference. So we can just find the displacements between 0 and 9, right? We know that at 0, the particle is at point A. We know at t equals 9, the particle is at point D, right? At time t equals 9, the particle reaches final position D on the positive x-axis. So it's just displacement. So displacement is just the integral from 0 to 9 of x prime. I don't have to know anything about y prime because between 0 and 9, this object has not had any, if we're just comparing between those 2 points, there's no change in a vertical component. So I just plug that in the calculator. I get -39.255. So if our x values change -39.255, then we know that the final and initial positions must be 39.255 units apart.
that I could be like 0, because don't we usually, this looks like negative 5/2 with 5/2. And isn't that something?
Oh, you mean for this year?
Yeah.
Question.
Yeah, you're right. We could have had this being 0, and that will just end up zeroing it. Actually, it would have given us like a negative, so we got like a -1, which is outside of our interval, so we can ignore that. But we can still have this to stand on, so point B is still at 2 = 3.
Like negative 5/2 to 5/2.
Yeah, you're right. With arc trig, with sine, positive is first quadrant, negative is fourth quadrant, negative power between negative √2 and √2. Yeah, let me look at this. I think this should have been purely at 0. And cosine should have been, yeah, this is right, but this one I think I should have just kept that 0. Yeah. Yeah, so this ends up giving us a negative value, which is outside of our interval, so we're only going to keep that 2 = 3 there. Okay, let's do one more here, page 12. Another particle motion. This is a calculator question, so when you get to the acceleration vector, you can just make the calculator, you can do math 8 on both dx dt and dy dt and get those horizontal and vertical component values of your acceleration. Okay, part B, find equation of the tangent line.
Why can't you take like distance traveled and divide it by time to answer?
I'm sorry.
Why can't you like take distance traveled and divide it by time?
If you take distance traveled divided by time,
Add the inverse.
distance traveled divided by time, that's going to be like meters divided by time. That'll be like meters per second, which is a rate, right? That'll be velocity.
Okay. Then what's the unit of speed?
Um, same. It's like meters per second, inches per second. Yeah, speed would just be if I just strip away that interval there. But if we accumulate all the different positive speeds over the course of my interval, I'm going to get my total distance. Part D, find the x coordinate of the position at time t equals 3. Final equals initial plus displacement. Or if you want to write it this way, we can say x of 3 is equal to x of 0 plus the integral from 0 to 3 of x prime. You know, the final equals initial plus displacement, maybe this is more straightforward than what we've done before, and use that to help you get to your final equation. Okay, can we just start problem 22? We'll just do 5 minutes, see if we can finish, see if we can make progress on page 22. And then your homework tonight is to finish page 22 because tomorrow I'll be checking page 11, 12, 21, and 22. We've already done 3 of those 4 problems. So see if you can get maybe half of page 22 done, and then the rest you can do later. So page 22, let's do another Taylor series problem.
Is there going to be these like area problems on the
Yeah.
test on Friday? No? Yeah.
So bad. I forgot. Guess we can see.
Oh, just want to point out, as I started looking at some of your tests, when the problem says to write a 6-degree Taylor polynomial, that doesn't mean that you're just going to write the 6th-degree term. It means to write every term up to that 6th degree. So when it says write 6-degree Taylor polynomial, you want to list out all the degrees up to that 6th degree. So, yeah. Now, if it wants the 6th-degree term, it would have to say term, but if it says polynomial, it is asking for the sum of the terms up to that 6th degree. There's a formula that allows us to fill in that numerator portion of our Taylor polynomial. And then part B says write we have to kind of create a general rule. And if this is n equals 1, this is n equals 2, n equals 3, we kind of play around with our n values to create our rule. And then if we can create our rule, then we can clean this up and turn it into the coefficients when n is equal to 1. Or when n is greater than or equal to 1. So we can clean up the factorials and get it all the way down to this. Yeah. Okay, so your homework due tomorrow. We did a lot of it in class. So page 11, 12, 21, and 22. Tomorrow we'll still maybe do one or do one of each problem, but I do want to start moving into limits and continuity and AB review packet. Okay, all right, come get your phones. Okay, that's.
Question about the FRQ.
Okay,
So on the actual exam, will we ever be given a calculator for the Taylor series problems?